Hello, welcome to my channel. Find the values of a, b, and c so that the graph of y equal to x squared plus a all over bx plus c has a local minimum at x equals 3 and a local maximum at -1, -2. We are going to find the values of the constant a, b, and c. The solution of this problem involves the creation of three equations. Now, since the point -1, -2 lies on the graph of the function, we can say that the value of y is -2 when x is -1. I'm going to substitute x with -1 and y with -2. I'm going to simplify this equation. So now I have -2 equal to a plus 1 all over c minus b. I'm going to multiply the left side and the right side of this equation by c minus b. I'm going to simplify the right side, and I'm going to distribute the -2 at the left side. I'm now going to transpose a to the left side. So I have my first equation, -a plus 2b minus 2c is equal to 1. This is the first of the three equations that we are going to make. Now, since the problem mentioned that there's a local minimum at x equals 3 and local maximum at x equals to -1, we can say that 3 and -1 are critical numbers. If you recall, we can only say a number is a critical number if the value of the derivative at those specific numbers are either 0 or undefined. So let's look at the derivative of our function. Here's again our function, y equal to x squared plus a over bx plus c. I'm now going to get the derivative of this function by applying the quotient rule. We know that at x equals to -1, the derivative is either 0 or undefined because we know that -1 is a critical number. The derivative function will only be undefined when the denominator of the derivative function is exactly 0. I'm now going to substitute x with -1 in the denominator and equal that to 0. If we are going to extract the square root of the left side and the right side of this equation, we get -b plus c equal to 0, in which case we can say that c is equals to b. I'm now going to show you that when x equals -1 and b is equal to c, the function will not be defined. Let's go back to our function. If we are going to substitute into the denominator of our function -1 for x, and if we substitute c with b, we will have b times -1 plus b in the denominator, in which case the denominator will turn to 0, and the function will not be defined. But we know that when x is equal to -1, the function itself is defined. In fact, the value of y is -2. This goes to show that when x equals to -1, the derivative function is not undefined, and therefore the derivative function has to be equal to 0. Now we are going to look at the case when the derivative function is equal to 0. We know that a fraction is equal to 0 only if the numerator itself is 0. So here's again our derivative function. This derivative function, when substituted by -1, will only be equal to 0 if the numerator itself is 0. Now I'm going to substitute into the numerator the value -1 for x and equal that to 0. If you are going to simplify this expression, we will have -b plus c times -2 minus the quantity 1 plus a times b equal to 0. I will now distribute -2 and b. I will now simplify this equation, and I will combine like terms. So this is my second equation. This is equation because at -1, the value of the derivative function is exactly 0. Now, similarly, when x has a value of 3, the derivative is also either 0 or undefined, because once again, 3 is a critical number. Here's again our derivative function. Let's look at the case when the derivative function is undefined. Just like before, the derivative function will be undefined if the denominator itself is 0. I'm now going to substitute 3 into the x of the denominator and equal that to 0. By equating, or rather by extracting the square root of the left side and the right side, we'll have 3b plus c is equal to 0, in which case c is equals to -3b. Similarly, I will show you that this is an impossible situation. When x has a value of 3 and c is equals to negative 3b, our function will lead to an impossible situation. So let's substitute 3 into the x of the denominator and c with negative 3b. As you can see, the denominator of our function will become 3b minus 3b, in which case the denominator will be 0, and therefore the function itself is not defined when x is equal to 3. Therefore, we can say that at x equals to 3, the derivative is 0 and not undefined. So here's again our dy dx. We are now going to say that when x is equal to positive 3, the derivative function is equal to 0. And the fraction is equal to 0 only if the numerator is 0. So now we are going to substitute 3 into the x of the numerator and equal that to 0. We are going to simplify. I'm now going to distribute the 6 and the b. I'm now going to collect like terms. So I have my last equation, 9b plus 6c minus ab is equal to 0. So we have now three equations. Here are our three equations. The first equation is coming from the fact that since negative 1 and negative 2 is a point on the graph of the function, we conclude that negative a plus 2b minus 2c is equal to 1. This is our first equation. Now also, since x equal to negative 1 is a critical number, we concluded that b minus 2c minus ab is equal to 0. And finally, since we know that positive 3 is also a critical number, we concluded that 9b plus 6c minus ab is also equal to 0. So we have three equations. Now let's look at again our three equations. So here's our first equation, here's the second, and here's the third equation. Now if you are going to look at our third equation and as well as the second equation, as you can see that if we are going to subtract them, we will be able to eliminate ab. So we will have now 9b minus b will give us 8b, and 6c minus negative 2c will give you positive 8c. If we are going to divide by 8, both sides, then we will have b plus c equal to 0, in which case we can say that b is equal to negative c. Let's take a look at our second equation, and also we know that b is equal to negative c. I'm now going to substitute negative c into b. Let's multiply and simplify. So we can combine like terms, so we have negative 3c plus ac is equal to 0. I'm going to factor out c because c is a common factor. And now I'm going to equate c equal to 0 and negative 3 plus a equal to 0. And so therefore I can say that either c is equal to 0 or a is equal to positive 3. Here's once again our three equations. We also know so far that b is equal to negative c and c is equal to 0 or a is equal to 3. I'm now going to show you that it's impossible for c to be equal to 0 while b is equal to negative c. If b is equal to negative c and c is equal to 0, then by substitution we can say that b is also equal to 0. I'll show you that this is impossible. Let's look at our function. We have x squared plus a in the numerator and we have bx plus c in the denominator. If you are going to substitute b in the denominator with 0 and you multiply that by x, naturally it will give you a 0, just the same, and c is also equal to 0, so you will end up with 0 plus 0 in the denominator, in which case our function will be undefined. So therefore we conclude that it's impossible for c to be equal to 0. As such, we can say that a is equal to 3 and b is equal to negative c. We are now going to use the fact that a is equal to 3 and b equals to negative c to find the value of the remaining variables. So here I'm substituting a with 3 and I'm substituting b with negative c. As you can see, I can simplify. I will combine like terms. I will transpose negative 3 to the right. And now I will be able to simplify further. and I found the value of C to be negative 1. So I have the value negative 1 for C and A to be 3. So therefore, B has a value of negative times negative 1, and that gives us B is equals to positive 1. So finally, we found the values of the three constants A, B, and C. We know now that A has a value of 3, B has a value of 1, and C has a value of negative 1. I'm now going to substitute these values into our function. So y now will be equal to x squared plus 3 all over x minus 1. I'm going to show you that this function satisfies what is given in the problem. We are now going to check whether or not the point negative 1, negative 2 is on the graph of this function. We can do that by substituting x with negative 1 and see if the value of the function is really negative 2. I'm now going to substitute negative 1 into x. I'm going to simplify the numerator as 1 plus 3 and the denominator as negative 1 minus 1. This gives us 4 in the numerator and negative 2 in the denominator. And as you can see, the value of y is really negative 2. This proves that negative 1, negative 2 is really a point on the graph of the function. Now we are going to investigate whether the derivative at x equals 3 and x equals negative 1 is really 0. We are going to get the derivative of our function again by using the quotient rule. I'm now going to substitute 3 into the x. If we are going to simplify this, we will have 2 times 6 minus 9 plus 3 in the numerator. And as you can see in the denominator is 2 squared, which is just 4. So we will have 12 minus 12 in the numerator and 4 in the denominator. As you can see, the value of the function, or rather the value of the derivative function when x is equal to 3 is exactly 0. We are now going to do the same thing at the point where x equals to negative 1. I'm going to substitute x with negative 1. I'm going to simplify the numerator, and I have negative 2 times negative 2 minus the sum of 1 plus 3. As you can see, the numerator is 4 minus 4, the denominator is 4, and therefore the value of dy dx is equals to 0. This proves that when x is equals to negative 1, the derivative function is equals to 0. So this proves the fact that all our answers are correct. Therefore, the value of A is equal to 3, the value of B is 1, and the value of C is negative 1. Thank you.